This is your review prior to the activities 9 through 11 quiz. So again, I'm not going through every single problem that's on the review, but I am kind of picking through at least one of each concept to just basically go back over and reteach if you're struggling with any of those individual concepts. So the first one I want to look at on the first set of pages, and I drew these lines in here to separate the three different pages. So this all above the first line is from activity 9. And so in number 3, they had given you the table and it asked you to calculate the slope. So of course we calculated slope a bunch of different ways, but from the table, remember that slope is delta y over delta x. And in order for something to be linear, the slope has to be consistent. So delta y over delta x you get from, finding the difference here. So 14 minus 20 is negative 6. That's delta y. Then delta x, negative 3 minus negative 4 is 1. So that gives me negative 6 over 1, which is negative 6. Now, in this case, that's really all I have to do because it just asked me to find the slope. But if this had asked if it's linear, I would need to keep going and check all the delta y, delta x's. So negative 4 minus 14 would be negative 18. 0 minus negative 3 is 3. So the reason why I wanted to do this, even though you don't need it for this problem, is to point out because some of you have the misconception that if you do these little, delta y things and you don't get the same thing, that it's not linear. But that's not true. It's when the differences aren't constant that it's not linear. Here they are constant because although negative 6 and negative 18 aren't the same, it's still proportional. Because if I do delta y, negative 18, over delta x, which is 3, I get the exact same thing, negative 6. And the same thing is true with this last pair. Negative 6 minus negative 4 is negative 12. 2 minus 0 is 2, and negative 12 over 2 is also negative 6. So don't get caught up in just making sure that these are always the same. These are only the same if the difference between your x coordinates is always the same. It's delta y over delta x that always stays consistent. Number 4 told you that these 2 points were on a line, and then it asked you for the y coordinate, or it asked you what is the x coordinate, so that's what we're trying to find, when y is negative 3. So the first thing I did, and there's several different correct ways that you could do this, but what I did was just graphed the points that I had, so 3, 4, 5, 6, 7, 8, 9, 10, 1 is right here, 5, negative 5 is way down here. Now, you can't just try to blindly connect the dots. Now, if you're using graph paper and a straight edge, you certainly could just connect the dots. But the problem with a hand-drawn graph is it's not always going to be scaled exactly correctly. So if you just do this and try to look for when y is negative 3, it might be off a little bit. So in this case, I would actually suggest going ahead and calculating the slope. So we already reviewed one means of slope, which was delta y over delta x. Now we're going to review the slope formula, which is y2 minus y1 over x2 minus x1. So when I look at my points here, my first point is always x1, y1. My second point is x2, y2. So if I plug into the formula, I end up with negative 5 minus 1 over 5 minus negative 10. So that gives me negative 6 on top and a positive 15 on the bottom. So they're both divisible by 3. That gives me negative 2/5. The reason why I wanted the slope here is because then I can actually find the exact points in between. So remember that the other thing that slope is rise over run. So we've reviewed all the major ones. Delta y over delta x, rise over run, y2 minus y1 over x2 minus x1. So this means go down 2 and write 5. So down 2, write 1, 2, 3, 4, 5. There's a point. That one doesn't have a y-coordinate of -3, so that's not the right one. So then go down 2 again, and then write 5. 1, 2, 3, 4, 5. I land right here, and lo and behold, that point, which is 0, -3, has the correct y-coordinate, which means that is why my answer is that the x-coordinate is 0, because that is the x-coordinate that has the correct y-coordinate. Next one I want to look at is number 10, which it goes back to this rise over run thing. Now for number 10, I'm going to need to show you the picture. So this is the graph that you had in your book, and it asked you to calculate the slope from the line that's graphed. So this means you need to draw the little triangle. So I can't physically draw on the web page, only on the PDF, but I see an exact point here. I also see one down here. There's one here. It doesn't matter which ones you use, but let's say I use these two because they're pretty easy to see. If I draw the triangle here, then my run is the horizontal distance. My rise is the vertical distance. So on that triangle that I would draw between those 2 points, that would look like this, the run, the amount of spaces, if you count them, 1, 2, 3, 4, 5, 6, 7, 8. So I've got a run of 8. My rise, I went down 1, 2, 3, 4. Remember, when you move down or left, those are negative values. So I've got my rise, I've got my run. Slope is rise over run, which in this case reduces to -1/2. Now, you didn't have to pick those 2 points. If you picked another 2 points and got the same answer, that's great. Nothing wrong with it. If you identified the ordered pairs and then did what I did in number 4 and just used the slope formula, that's perfectly fine as well. Number 11 is a word problem, so we'll look at it here. Juan earned $7 per hour plus $20 per week making picture frames. A wanted us to write a function to represent Juan's total earnings if he works X hours. So it says $7 per hour. The per tells you that this is the number that is going to be attached to the variable. So 7 times X, I know I'm going to have. And then it says $20 per week. Now you have to be careful here because you see another per and sometimes people want to attach it. But this says the function is for just 1 week, which means that the $20 is a flat rate that he gets for that particular week. So that is why when I wrote this, I said that g of x equals 7x plus 20. Because if I'm only writing a function that describes a week, he's getting $20 up front plus the $7 per hour. That's part A. Part B says determine the slope, and it said without graphing. So remember that another thing that we learned about slope is that it's always the coefficient of the variable. So 7 is the coefficient of the variable, so that means the slope is 7. Then C asks us to describe the meaning of the slope. So that means it's just saying what is 7 in the context of the problem. So you can even go back to the problem if you want. It's $7 per hour. So I would say the slope represents the hourly rate, or the slope represents that Juan earns $7 for every hour or per hour. So any of those variations are good descriptions of the representation, the meaning of the slope in the context. Number 13 is the next one, and this one has another table. So we've got x and y, -3, -1, 0, and 1. The corresponding y's are 44, 4, -1, and 4. So the question asks you to tell whether the function is linear and to justify it. So if I'm trying to determine if something is linear, remember I'm looking for delta y over delta x. So if I look here, 4 minus -1 is 5. 1 minus 0 is 1. So here I get delta y over delta x is 5. If I go up to the next set, -1 minus 4 is -5. 0 minus -1 is 1. So when I look at those, then I can see that I'm not getting the same thing. Now I would probably do the last one just to make sure. Here, delta y over delta x, I got -5 this time. Between 4 and 44, 4 minus 44 is -40. -1 minus -3 is 2. -40 over 2 is -20. So I did not get the same slope the whole way, so that means no, it is not linear. So you would write no, and it did say to justify. You would say because the slope isn't constant, or because there isn't a constant rate of change, or because delta y over delta x isn't constant, something along those lines. All right, I have marked to look at 18 and 19. They must be ones where you have to look at the picture. And for some reason, my thing doesn't want to scroll here. There we go. Oh, identify the slope from the picture. So the reason I wrote it but don't have any spaces because there is no work for this. This is what you just have to know. In our book, in this section, at the very end, there was a picture of all 4 types of slopes that you could have and what type of slope. We filled that in the chart. So this is a vertical line. Vertical lines are always undefined. You just have to know it, so make sure you study that. This one, in 19, it's falling to the right, which means that that is a negative slope. So what you should be looking at again, and I'm trying to use different colors so this will stand out. If you have a line that rises to the right, that's positive. If it falls to the right, that's negative. If it's horizontal, the slope is 0. And if it's vertical, the slope is undefined. And I can't fit the word undefined there, but we did just go over that one. All right, so that takes care of activity 9. Then we moved on to activity 10, which was direct and indirect variation. I wrote up here the formulas because you absolutely need to know the formulas. So direct variation always takes the form y equals k times x, which means that if you were looking for the constant of variation, meaning if you don't know it yet, you would just do y divided by x to find it. Note that these two things are the same thing. They're the same thing, just solved for a different variable. Same thing over here with indirect variation. Here, y equals k divided by x, which means that if I was looking for the constant of variation, I would get it by taking x times y, because that's how I would get k alone here, is by multiplying by x. All right, so if we look at just a few of the example problems that are in your review, number 1 says that the value of y varies directly as x, and when y equals 125, x equals 25. What is the value of y when x is 2? So as soon as it says direct variation, I immediately write the y equals k times x. Then it doesn't tell me the k, it tells me x and y. So the next thing I'm going to do is calculate the k. K equals x times y. Now it says y is 125, or not x times y, that's the other one, y divided by x. It says when y is 125, so I put that in for y, x is 25. So I do 125, I divide it by 25, And then that's going to allow me to find my constant of variation. So that's 5. So that means that the direct variation equation that would describe this situation is y equals 5x. That's useful because it asks us what's the value of y when x is 2. So all that means is I plug in 2 where x was. 5 times 2 is 10, so that means y would be 10 when x is 2. Have a note here to look at number 2 and number 3. Sorry, it takes a minute. I've got to jump to the next set of pages. So lesson 10 practice now. So number 2 was multiple choice, and it asked which one is direct variation. So I wanted to go over this because it is a major concept that you need to know. Direct variation graphs are linear and go through 0, 0. So this is linear, but it doesn't go through 0, 0. B, linear, goes through 0, 0. So B is definitely it. C doesn't go through 0, 0, and neither does D. So that is why the solution is B, because it is a line and it goes through 0, 0. Similar idea for number 3, except with the equation version. Again, we've got y equals k times x. Now, I always get people that get confused on this. That's why I wanted to go over this one. This is very obviously k times x. But this one is k times x as well, because the x is still on the top. So that just means that k here is 1/3. 1/3 times x is x over 3. So this is direct variation. It is taking the form y equals kx, where k is 1/3. Same thing is true with D. Here k is a fraction, so it looks different, but that is k times x, where k is 5 over 2. The one that is not direct variation is C, and that's because my variable's in the denominator. So k isn't being multiplied by x, k is being divided by x. So the x needs to be in the numerator or right next to the k value. So C is not direct variation there. All right, the next one that I wanted to look at is number 7, and that one is sort of like number 1 is, in that it gives you values and you have to find another one, except it's a word problem, and it's talking about indirect variation. So make sure that you read carefully on the quiz to see whether it says direct or indirect. So this one says vary indirectly. Temperature varies indirectly as distance from the city. The temperature equals 3 degrees Celsius when the distance from the city is 40 miles. What is the temperature when the distance is 20 miles from the city? So, as I look at this, I know that they've given me an x and a y value. That the temperature is 3 when the distance is 40. So that means I need to know k. So for indirect variation, that's up here, k is equal to x times y. So k is going to equal, in this case, 3 times 40, because those are my x and my y values. That gives me 120. So now I know that y equals 120 divided by x. This is the formula that's going to describe it. So if it wants to know what the temperature is when the distance is 20, then that just means that I have to plug 20 in for x. So y, or the temperature, is going to be 120 divided by 20. The zeros cancel out. 12 divided by 2 is 6. So that means it's going to be 6 degrees Celsius for our answer there. Next one I marked to look at is number 13. This one also has a table, and 14 goes with it, same type. So if we look at number 13, it says use the data in here to write a linear function. So we did this when we did our cup data. So if you want to go back and look at something in the lesson, that's where we did something just like this. So what I need to do first is to find the slope. Now, conveniently for us, our x's go up by 1. So if I do delta x, these are all 1s, which means that the slope, delta y, should be the same, meaning it should be going up by the same amount each time. And as I look, it is. It's going up by 3. So I know then that I'm going to have, and did it say function? Yes, it said linear function, so that means I need f of x and not just y. I know f of x is going to be 3x, and then I'm going to have plus or minus something on the end. I have to figure out what that is. Remember that these table values are ordered pairs. If I go to the first row, that should represent the point 130, which means when x is 1, y should be 30. So I don't know what this is, but if I plug these in for x and y, I can figure it out. So f of x is the same as y, so 30 equals 3 times 1 plus what I don't know. So this is 30, this is 3, subtract the 3 on both sides. I now know that this needs to be a 27 in order to work right in the equation. So f of x equals 3x plus 27. That's how I came up with that function. The next one, number 14, I believe, asked, chairs cannot be stacked higher than 5 feet. What is the maximum number of chairs Jeremy can stack? So first thing that is a little bit tricky on this is that the heights are given in inches. So you have to know 5 times 12 is 60 inches. So 60 inches is the maximum that you're allowed to stack. How you get that could be a bunch of different ways. You could just continue the pattern from the table until you get to a height of 60 and see what the number of chairs is. That probably takes a little longer than using the function, which is what I would do. So that if 60 inches is the limit, then I just do 60 equals 3x plus 27. I subtract 27, which gives me 33, equals 3x. Divide by 3. I see that x is 11, so that means that it would be 11 chairs. That would be the maximum. All right, we should be getting to the stuff that hopefully you have not forgotten since we just did it, but that is sequences. So that's our final major topic here, is sequences. So when we are looking at sequences, and I have to switch again to go down to activity 11, so it's going to think for a second. There we go. So the first problem that I wanted to do was number 4, and it is multiple choice. So which of the following is not arithmetic? Remember that arithmetic is going to have a common difference. So 1 minus 1/2 is 1/2. 3 halves minus 1 is 1/2. 2 minus 1 1/2, 1/2. So it's not this guy. 14 minus 11, 3. 3, 3. Not that guy either. 4 minus 2, 2, 8 minus 4, 4. So it doesn't matter that there's a pattern. There is 2, 4, 8. It's doubling. That does not matter. It is not the same difference each time. So that is why C is the answer to number 4. Next one, number 5, I wrote out the sequence. It just asks you here to find the common difference. So same thing that I just did in 4. So finding the common difference here between each set should be consistent. So if I do -1 minus negative 2.3, remember that that turns into a plus. So this becomes -1.1 plus 2.3. Which then gives me 1.2. So then I check 0.1 minus negative, which becomes a plus, 1.1. That gives me 1.2 also. Check the next one, 1.3 minus 0.1, Yes, that gives me 1.2, so I'm sure that this is my common difference. Number 9 asks me to determine the explicit formula. So remember, explicit formula, a sub n equals a sub 1 plus n minus 1 times d. You have to know the first term and the common difference to get started. So in this case, my first term is obviously 3. I need to find d, my common difference. So I can find that here. Negative 3 minus 3 is negative 6. Negative 9 minus negative 3 is also negative 6. Same thing here. I had suggested when we went through these in the lessons that you put this in parentheses so you wouldn't think it was subtraction, because this is to be multiplied times the n minus 1 in our next step. So I've got 3, and then negative 6 times n is negative 6n. Negative 6 times negative 1 is positive 6. So then when I combine like terms, I've got negative 6n plus 9. And so this is my explicit formula. Number 12 gives me the 9th and 10th terms of an arithmetic sequence. Now, this is a lot easier than some of the ones that we did. These are the ones where we drew the picture, and so we did a sub 9, and I wrote underneath negative 24 and then negative 30 underneath here. These happen to be consecutive, so I don't like this example very well. We did lots of them in the lesson, so you can go back at those if you think you forget them. But remember, if there's multiple common differences, you know, these are all d between. But here it's just one common difference, so negative 30 minus negative 24, which gives me 6. So I'm trying to find the 30th term, it says. Now, since it didn't ask me for the explicit formula, that means that I can actually just go ahead and plug everything into the formula here instead of doing this and then doing another step. But remember, if it asks you for the formula first, you have to do like we did in number 9. Oops, and that's negative 6. What am I doing? Sorry. So if I'm trying to find, in this case, the 30th term, the 30th term means that n is 30. So I can use this formula to help me figure out A1 first, because I need that. You could also count backwards if you want to add 6 instead of subtracting 6 all the way back to A sub 1. You can do that. But what I'm going to do is I'm going to say, okay, I know when n is 9 that an is negative 24. So I put negative 24 in for an. I don't know a1. I know that n is 9 when an is this. So 9 minus 1 times d, which we already said was negative 6. So that gives me negative 24 equals a sub 1, and then minus, because this is going to be 8 times negative 6, so negative 48. So I add 48 to both sides. That tells me that my first term was positive 24. And so now I can find the 30th term by saying, okay, a sub 30 is going to equal a sub 1, which is this guy, 24, plus 30 minus 1 times negative 6. So that's going to be 24 and then 29 times negative 6. 29 times negative 6 is negative 174. So then we've got 24 minus 174, which gives us then negative 150. So for number 12, then your a sub 24 should be negative 150. All right, one note here that was reminded to me that there's a typo in the book. So if I didn't remember to tell your class today, if you look on page 171 at number 6, the sequence they listed was -9, -13, -18, -23, and they said in the directions that it was arithmetic. As they typed this, this actually is not, because it doesn't have a common difference, but I'm pretty sure there was an earlier version of the book where they didn't have this typo. Just change this first term to -8, and then it all makes sense as an arithmetic sequence with the correct common difference listed on your answer sheet. All right, next one is number 16. So if you look at that one had a graph. So if you missed it, look back at the book. It's got a graph there. It says write a function to describe the arithmetic sequence graphed below. Then find the 5th term of the sequence. Use function notation in your answer. So you'll notice that on this graph, and I picked this one because it's the harder one of the two that are graphs. On this graph, they do not show you what a sub 1 is, because that would be when x is 1. So they've given you when x is 15, and they've given you when x is 9. So what I actually did here is I made this into a problem where I kind of drew a picture. So I wrote out that f of 9 equals 3. So f of 9 equals 3, which is the same thing as saying a sub n equals, or a sub 9 equals 3 rather. Then the other one they give you is a sub 15 equals 9. So that means f of 15 equals 9 as well. So I drew a picture. So I started at a sub 9. Sorry, my little pen got carried away. And then I did the common difference, kind of little swoopy things. So 10, 11, 12, 13, 14, 15. So I landed a sub 15. A sub 9 was 3. A sub 15 is 9. So in between these two values is a difference of 6. If you count how many common differences we have there, there's 1, 2, 3, 4, 5, 6 common differences. So what we did in class is we said if there are 6 common differences and the difference between the entire distance is 6, that means in this case 6d equals 6, which means the common difference is 1. So then that allows you to either count back to find the first term or use the formula to find the first term. You can do it either way. So because it's counting by ones, in this case it's probably just easier to count backward from the value at a sub 9. So I know that a sub 8 then would be 2, and then 1, and then 0, and then -1, and so on and so forth. If you keep counting backward, you will find that your a sub 1 is -5. So once you know the first term and the common difference, then we plug it in. So f of n, because it said use function notation, equals first term plus n minus 1 times the common difference. Since the common difference is 1, distributing 1 doesn't change anything, so that gives us -5 plus n minus 1, which then gives us a final answer for our function of f of n equals n minus 6. It did ask in number 16 for you to find a specified term as well. If you look back, it says find the 5th term of the sequence. Now, if you counted back, you would already know what the 5th term of the sequence is, and in that case, you could just, write it. In this case, we would plug in and find f of 1, so 1 minus 6, which gives us, or not 1, sorry, the 5th term, so 5 minus 6, which gives us -1. So the second part of the answer there in 16 is -1. All right, last one is number 18, and this one's pretty easy. It says an arithmetic sequence is described by the function f of n equals -3n plus 7. So f of n equals negative 3n plus 7, and it asks you to determine the first 5 terms. So the only thing I wanted to point out with this one is just when you're starting a sequence, you're starting when n equals 1. So you start by plugging in 1. So negative 3 times 1 plus 7 gives you 4. Then plug in 2, 3, 4, 5, until you get to the 5th term. And so then that gives you the answer: 4, 1, negative 2, negative 5, negative 8. Hope you enjoyed the announcement music, and that's all.